There must be thousands of code generation tools, scripts, accelerators, vendor platforms, add-ins for tools, all focused on making sure that data warehouse development can be sped up. You've got things in SQL, in Powerdesigner, in C#, any sort of language really, modeling tools, ERwin, in Excel, in Excel, in Excel, Excel, SQL, more Excel. You get the idea, right? In fact, I only know a few people who have not been working on a tool of their own for use in their project. Especially in this audience, I suspect that the majority would have worked on such a solution at some point. I certainly have. And developing a good data solution is not easy, right? It's difficult. It requires various concepts to play well together and to be implemented correctly. With so many tools, we have so many options and variations of the same theme. Some are better than others, and at least in some areas they would be. And I'm not sure that we're always doing our customers, ourselves, a favor by introducing yet another custom solution. So my name is Roelant Vos. I'm a data warehouse professional and an automation enthusiast. And I look forward to discussing some ways of collaboration today with you, my peers, right? That I believe are beneficial to our solutions, our customers, our relationships as data professionals, and also ourselves in general. So I've been working in the data area in different roles and looked at it from different perspectives. I've been a consultant, I've been a trainer, I've been a manager of large teams working on solutions such as these, and I've been a corporate decision maker. Now I'm working at a software vendor, the first time in my life, the vendor for data warehouse automation, Vergence. You may have heard of BIML, especially if you're in the Microsoft space. It's basically those guys, and they've got a data warehouse solution, data warehouse automation solution called BIMLflex, and I've just started working on that. Developing data warehouses is not always easy, and there's many options to evaluate and considerations to make and frameworks to apply. And when we design and deploy a data solution, we aim to integrate all these concepts and frameworks and everything into a working, coherent deliverable that ideally does everything that we intend, and it does it perfectly. At the same time, we often work independently and in parallel on these topics, but that can be really complex. And even while the projects that we do are or can be very similar in nature. So sometimes we even keep the secrets, close to our chest, sometimes too close, in my in my opinion. So let's try to find some common ground, a way to exchange the information that is common across our work, right? The design metadata. So we can collaborate on it and we can continue to make delivery of these data solutions easier and better, while everyone still gets to use the tools and the technology and the concepts that they like and are familiar with. And the design metadata in this case is pretty much everything you need to generate your solution. By using such an approach, you may still be able to use the same tools and patterns that you prefer. At the same time, we may be able to save time by reusing other people's ideas, right? And to stop reinventing the wheel. And using an agreed format to exchange this design metadata also helps to allow you to focus on what your core strengths are, the things that you're really passionate about, that you're really interested in. Some solutions, they've got great metadata management. They've got really good ideas on how that should work. Some have really good modeling components. Some generate great code, and some have really good control frameworks or ways of managing conventions that you can then apply to generated output. So there's a lot of strength to play on. We don't necessarily all need to do everything every time. Now, you may think, how can any generic schema be sufficient to store all the complexity that I have in my solution, right? So all the metadata I need to support my frameworks and my automation. But actually, in most cases, there is a core of design information that is consistent across projects. For example, in most cases, there is the notion of data going from A to B, or it's interpreted this way using a view or some bit of logic. It's the same difference. After various workshops and projects, the schema is pretty stable, and it can always be adapted, right? Nothing is ever nothing will ever be the same. There's also a concept of key value pair extensions that you can apply to support specific requests, and so far that has been perfectly fine without any concessions needed to be made. I will talk about that later a little bit. The approach itself is not tied to any technology or modeling paradigm or approach, and it would be fine to build dimensional models, data vault, anchor models, third normal form models. There's not really anything that prevents you to pursue a certain solution direction. And it's up to you which part you use and which part you don't use. So it's even possible in principle to relay different models together. For example, the link between a conceptual and logical model, or logical and physical. It's really how you use it. And even if you use a repository in your environment or your tool to manage the metadata, that's compatible too, because it's really easy to write an adapter that can interface with a schema such as this. The added advantage is that if you store the metadata separately, and in this case, it can be stored in a JSON format or something similar, it's text-based, it's easy to version control, and it's easy to share around. It's usually much easier to merge these kinds of artifacts, these text-based artifacts, into each other, right? In terms of managing versions in general, than it is into a database, and therefore it also leads itself very well to DevOps. Text-based makes life easy when you work in different teams across different areas, contributing to the same solution.
Roelant, there are questions in the chat if we are stuck on the same slide or if this is intentional.
Oh, imagine how much we can work to accomplish work together, right? So that's the right one.
Okay, so this is intentional.
Yeah, this is intentional. Yeah. I don't want to have too many slides, but I'll come back to that in a bit.
Okay, great.
But thanks for checking. Yeah, so I guess what I was saying, so using these text file artifacts to store this metadata, it makes it also easier to merge it back into a repository if and when you want that. And in some cases, the available automation tools, they do work somewhat like a black box, right? And some require all data processing to be done internally behind the scenes. And it sounds convenient, and it can be, but it can also force a lock-in using concepts or approaches or technology that you may not like as much. Everything is usually fine unless you want something different. And then, we are still figuring things out, and these concepts are evolving. There are definitely areas that, that we still have to sort out. And sometimes these accelerators or these sort of do-it-yourself frameworks, they can be seen, especially by the creator, and I'm one of them, as the bee's knees, right? They're worthy of the most strictest of IP protection. Personally, I think the magic of automation is not really about the code generation at all, but it's in the way we design, we manage our design metadata. So yeah, let's dive in some details. So time is a bit short. So let's save the questions to after the session, as per Christian's setup, which makes sense. The deck that will be distributed has a couple of additional slides. So I've added a bit more detail in these distributed slides, so I don't sort of spam you with lots of complex diagrams, and focus on the talking a little bit. The slides also have my my contact information. So if you want to discuss any further topics or use cases, feel free to reach out. And the deck also has a link to the repository where all this stuff is managed. Right. So the idea behind the schema for data warehouse automation essentially is to separate the management of the design metadata from the storage. And again, the design metadata is the information you need to generate the files or database structures and the data logistics processes that you output to interact with these structures. And if you consider data warehouse automation as a bit of a black box, then the design metadata goes in, and the artifacts are the output, and these are not only generated, but usually also operated in some shape or form. And what I'm basically saying is that if we break that up a bit and we say, let's separate the way we work with the metadata, which is design metadata management, with the way we store the design metadata and the way we use it, we make things a little bit more flexible. And some tools, they do more than others, and they often do many things, and lots of knowledge is embedded in them. But from the perspective of metadata, we can just look at it like this, right? So we abstract out the complexity out control frameworks, logging, auditing, error handling, all those kinds of things. We're just looking at the design metadata. When we look at it like this, we can start applying different technologies. For example, we can use whatever tool we want to interact with the metadata. We can use third-party automation, third-party software. We can use our homebrew, which is the team application I built myself for this, which is an open source version of that. Excel, a repository, Powerdesigner, whatever, right? It doesn't matter. It doesn't matter because we read from and write to the same format anyway. So we don't need to align on the technology to do our design, but we can still work together because we agree on how we can exchange this metadata, and we can talk about how we want to use this design metadata to deliver outputs. And in fact, this is how the idea started, because 2 years ago, more or less, I was in a call with Florian and Torsten. I think they're both on the call. I know Torsten is because we just spoke. I saw Florian earlier in the lobby, I believe. But it was really about how we can work together on code generation templates using templating engines. However, they were using Pebble, I was using Handlebars, but the intent to work together is there. And while the technology is different, if we have the same schema, we can still do quite a lot. And the same applies to design decisions on what you can consider the best way to deliver a certain pattern. Do we need caching? Do we need lookups? Do we need ETL or ELT? The thing is, we don't really need to agree on that, right? If we do, great, right? Happy days, as they say here. But if we don't, then that's fine too, because we can talk about it, we can discuss it, and we can let the meritocracy play out. But it's independent of the design metadata. The design metadata doesn't change. So that brings us to the schema. Now, the schema for data warehouse automation is an open source project on GitHub. It has documentation, it has a class library, it has some sample metadata, it has some sample patterns, it has some validation and regression testing logic. But at the end of the day, it is a JSON schema definition. And in this schema definition, it lists out all the components that compose of this, that ultimately bring together this model to capture design metadata. As a JSON file, you can consume it in different ways, and that's all explained on the GitHub project, and it's probably takes a bit more time than we have today. But in its essence, you have the concept of a data object, which is a file or a query or a table or a container or something like that. And it's basically whatever you want it to be, right? It's a data set. A data object can have data items, which can again be things like columns or bits of logic or whatever. In a simple example, simple mapping, a data object would be a table, and a data item would be an attribute in that table. So that's sort of the simplest way to look at it, but it can be pretty much whatever you want it to be. Now, a data object can be mapped to a data object in a sort of a source to target sort of fashion. And this is what a data object mapping is. It brings together a data object, a source data object to a target data object with some properties. And in this example, the filter criteria and the classification are shown. And optionally, it includes a lower level mapping at data item level as well, from a source data item to a target data item. And in practical terms, these JSON definitions from the schema are instantiated as if they were classes in a more traditional object-oriented programming sense. So that's why I use the colon and the instantiation of the data object class into a source and target and a mapping between the two. The result is pretty easy, and it's a really practical way to document or to capture all kinds of data structures, the transformations ranging from super simple to extremely complex. I've prepared a couple of examples to show some plain text code generation using this approach. Again, as I said earlier, the magic, I think, is more in the way we manage our design metadata than it is to generate the output. I think generating code or generating ETL or whatever we want to call it, artifacts, pretty simple. And it does work the same way if you're using a software development kit or an API or third-party compilers such as BIML that outputs, stuff in whatever the native platform is, like ADF or SCS or things like that. So let me jump out of the presentation and really show a quick example of how that works.
Just for your information, you're now 15 minutes in.
Excellent. That's perfect timing. So thanks, Christian. So what we're looking at on the screen is an example of one of the simplest possible data object mappings you can imagine. And it says, I am the first mapping. That's the name. That's one of the properties you can assign to the mapping at mapping level. It has a collection of source objects that contains only one, which is table one source, and it has a target one target, which is the target data objects. So these are of the type data object, and also there is a mapping that has a column source to column target. Super simple. There's two mappings in here, so I can go in here and go in here to expand and see them. This is just a JSON way of documenting this. Now, this metadata storage can then be applied to a specific template. In the solution here, there's a couple of examples and data vault stuff and dimensional modeling stuff, but I'm just sticking to the simple one given the time. If I select again the simplest of template I want to map into that, then basically what I'm going to do automatically is to say for every element of this list of data object mappings, generate this stuff with whatever is in the object that it contains. I'll do this quickly. Need to check if I've got my right solution up and running, and it's fine, right? So you get two bits of logic that say, I select star from here, select star from there, and a note that it picks up the mapping name property. Now, this is super easy, right? And like I said, you can define this in very complicated ways to do all kinds of fancy business logic and things like that. But it's not the point. The point is that we separate the storage from the information to the application of the pattern, and then we can work together on the pattern or store it in our own repositories, right? And there's a lot of people I know that work, for example, in Sybase, and it's really a pity I can't really work with what they have because it's all built in their tool, and everybody is in the same direction, right? So it's sort of what I started with, and I think it's a missed opportunity. So that's why this has started. Now, one feature I'd like to highlight, and that's the extension point that I missed, that I mentioned earlier. Because at the end of the day, you can specify whatever it is you want that is in addition to the standard format as a key value pair and apply it everywhere, right? So it looks like this. This is a copy of the JSON schema definition that defines what an extension is. Cannot be simpler, right? It's an object, it has a key, a value, and a description, and you can connect it to whatever you want to add whatever specific information you need to store for your specific solution. By the way, even though I'm now working on for a software vendor, doesn't mean I'll stop working on these kinds of things in the open source community. I love these kinds of topics. It's always really good to be able to talk with you guys, with my peers, as I said, on these kinds of things. My contact details are on the slide. Please reach out if you want to know more. Summarizing, we've looked at how a generic schema can be used for data-aware automation, how it could work. This schema can help collaborate or help facilitate collaboration without forcing us into a specific solution or technology corner. It's an open source project. It's on the GitHub. It includes documentation, class library, validation, technique, regression tests, and all kinds of scripts and samples. And it works really by separating the design metadata management from the storage and provides a simple and easy way to read from and write to. If you have an automation tool or developing one, please have a look at what's already available here so we can work together. And trust me, I get emails from people starting to work on their own solution. No, maybe not daily, but definitely a couple of times a week, right? And it sort of goes back to what Frederick mentioned in the initial presentation. It's it's something we need to be mindful of, right? So custom solutions, it's not always the right thing to do. If we don't, you may miss out something on something that saves you time and makes it easier to connect to other frameworks and concepts that are evolving. And if you do look into it, you may find that you can focus on your core strength and the thing that engages you most a little bit more, and reuse some of these other components. So to wrap up, I genuinely feel that approaches such as these are in the best interest of ourselves and the projects we deliver. If we can at least agree on the basics, then we don't have to agree on everything specific, right? So we don't have to agree on how we use the metadata, and because that will work itself out naturally. We do not have to agree on the best way to implement X, Y, and Z. We can discuss it, and we should discuss it. But we should also let the meritocracy play out on that. But at least, hopefully, we can agree that fundamentally, we're all mapping data from A to B somewhere. So thanks for attending.